Okay, so Dr. Wolf, go ahead.
Okay, take it away. Thank you, Roger. It's a delight to be here. Thank you all so much for coming out on a Saturday. It's interesting to see and nice to see people taking that much of an interest in this subject on a Saturday. Since we're a little pressed for time, and I know there's lots more going on for everybody in an evening of a Saturday, I will just get started. So I'm going to be talking about the impact of microplastics and plastics in general on the human body. And I want to start out by giving you kind of my theory of how I stay sane when we're looking at a subject that can be very dark and very surprising. And my sanity comes actually from my having been initially a historian of medicine. And when you read a lot of history, you learn that history is not inevitable, that human choices make history, and that as you study them, you can often see the way that things have zigged rather than zagged. You can identify the individuals or the groups who made the decisions and think about why they did. And you can think up different options for different outcomes. So I started my work in medical history because I was interested in policy, and I was studying history to inform policy. The thing that I took away from that is that problems that are not inevitable are solvable. And most of the problems in medical history were not inevitable, but that's also true in environmental history, at least the way we think of it. It's not environmental history as in, the ice caps melted in the last ice age, and then there was a lot of erosion and so on and so on. This is modern environmental history where we're studying some fairly new phenomenon that are impacting our climate today and doing it fast. And they can be scary, but they were not inevitable and they are solvable. And that's especially true in the plastics crisis, where so much of it is so incredibly new that we can still identify who made the decisions that brought us where we are today. In fact, much of the time, those people are still sitting at the same desks that they were when they made those decisions. So there's plenty of hope. I see this as a solvable problem. I'm not enough of a masochist to hang out in a field that I didn't think was winnable. So here we go. What is the plastic crisis? Well, at first glance, it's a pollution crisis. It's a litter crisis. We've managed to create about 10 billion tons of plastic since 1950, and almost all of that is still with us. Frankly, the only exception is the plastics that have been incinerated. And when you incinerate plastic, you're incinerating a petrochemical product. You're doing a lot of chemistry. So you're creating things like dioxins, which are the most powerful carcinogens known to humanity. And that comes from incinerating plastic. So it's not a great option. And it's good that we haven't taken it that much, but it also means that we still have most of 10 billion tons of plastic hanging around. This means that there are very few plastic pollution deniers. People will walk outside their houses and immediately see the plastic everywhere. If you look at the ground, you'll see little fragments of lighters and straws. If you look at the trees, you'll see plastic hanging from them. It is everywhere. It's also everywhere fairly recently. This graph is interesting to me in part because more than half of all of the plastic that we have on the planet right now came to us since the year 2000. And that makes sense because
Dr.
new plastic
Megan,
generation. Uh-huh.
I'm not seeing your slides right now.
Ooh, that's not good. Okay. Hold on.
So,
Let's maybe I
yeah,
didn't share screen. Oh my gosh, I didn't share screen.
that's okay.
Durr, there goes my credibility. Haha.
That's all right.
All right. You know what? I'll just walk you through what that's the 10 billion tons of plastic. Thank you for bringing that to my attention.
That's
I
okay.
had never yet been that presenter. Okay, so there's 10 billion tons of plastic, and here's the curve. 56% of all of this plastic is just since the year 2000, and that's not too much of a surprise since we know that new plastics generation about doubles every 14 years. So we're right on target there. We also know, by the way, that plastic generation and plastic pollution have a one-to-one ratio with each other. The more plastic you make, the more plastic gets littered. And that's because plastic never breaks down in the environment. It can't. But the bigger problem here, frankly, bigger than the plastic that we have right now, is the plastic that we're about to face. Industry is aiming to triple production by 2060, triple it. That's not a secret. That's actually a response to people moving over to renewable energy sources. So if we're not going to burn our fossil carbons, we can make them into plastic. I'll come back to that. Well, like I said, yeah, it's now set to triple. But here's the other part of the problem. I'm sure all of you at this point have heard the term microplastic. It was only coined around 2005 by Richard Thompson. And a few years ago, the New York Times noted that it was one of the biggest words of the year, kind of like dumpster fire, where everyone's talking about it all the time. So microplastics are what happen as plastic breaks down. If you leave anything plastic outside on the lawn in the sun, you'll notice that it'll start to fade, it'll get brittle, and over time, it's going to be into little pieces. You see it especially on the beach. All those plastics washing up, those are, we call them ocean plastic, or in order to a euphemism for that is marine debris. We're supposed to call it marine debris. Ocean plastic, out in the waves, out in the sunlight, gets broken down even faster, and as it washes up onto the sand, you see little fragments. In addition to things like flip-flops and detergent bottles and so on, you see lots and lots of little fragments. And it was actually Richard Thompson, the guy who coined the term microplastic, who first started thinking about this while he was on a beach in England, and he picked up a handful of sand and said, "This isn't sand. A lot of this is plastic." So, okay, it breaks down. Microplastics are anything smaller than a pencil eraser. But of course, they keep on breaking down. They break down and break down and break down. Plastic is incredibly strong as a molecule. It's a synthetic, man-made molecule. Carbon-carbon bonds that are covalent, they do not break apart. So it never degrades, it just breaks up, and it breaks up to the point that it becomes literally microscopic, and then it keeps on going down. So nanoplastics are anything smaller than a micrometer, but they can also be a lot smaller than a micrometer. Now, as a result of their capacity to just keep breaking down, they're small enough to penetrate every corner of the environment. And that's frankly exactly what we're seeing now. Initially, the attention that went to plastic was ocean plastics, but the more we look, the more we find. So plastics have been found literally everywhere investigators have ever looked, from the top of the Andes to the bottom of the Mariana Trench. This is a microplastic filament on a snowflake. So this little filament came from a textile, and 70% of textiles right now are manufactured out of polymers, plastics. So it could have come off of anything from a fleece to the shirt I'm wearing right now. Probably most of you, I certainly am, are wearing some kind of a blend or some kind of a polymer. They persist in the environment and they're small enough to evaporate in the hydrocycle. And by the way, this is not just true of microplastic filaments. All microplastics and nanoplastics can evaporate into the hydrological cycle. And then they rain or snow down onto every part of the planet. And this is how it's come to be that they are so diffuse on the planet. Another way that they move around is wind. They get caught up in dust. They become literally dust. And so anywhere that the wind can carry them, they can go, and they do. So you'll find the same number, if not more, microplastics well inland as you will on the coasts and the shore. These are microplastics that have been caught up in the vasculature of a plant. Now, again, the more we look, the more we find. And what we're actually finding is that it's not the ocean basins and the waters that are the most heavily contaminated, though they are heavily contaminated. It's actually agricultural soil that has between 4 and 23% more microplastic in it than water. And this is partially from the practice of spreading biosolids on soil. Those can come from sewage treatment plants, and they're still going to have all of the microplastics that washed through the laundry, that washed into the sewers. But it's also from practices like extended release fertilizers and seeds, which are coated in plastics, and then the plastics then break down onto the field and leave even more microplastics on the field. So agriculture is saturated in plastic, and plants, including crops, are taking up that plastic. So again, if you're worried about micro or nanoplastics, it's not just seafood. We thought about seafood first, but it's actually all food. This is microplastics and nanoplastics on an insect that was located in Adirondack State Park a couple of years ago. And this is interesting, not just because it is so completely covered in plastics, but because Adirondack State Park is a pristine wilderness area, nowhere near any plastic production, any major plastic dumping or recycling or incineration of any kind. This is really what happens. This is how diffuse those microplastics can become on air, on wind, and water, that they can move in such incredible magnitudes to even the remotest places. So if it's in the air, if it's in the water, if it's in the food, well, we know it's in our food system too. It's in every corner of the food net. So there's not a lot that we can do to filter that out except dark humor. So here we have Roz Chast in the New Yorker, flour, sugar, coffee, tea, microplastics. How small are some of those microplastics? Well, to give you a sense, over on the right-hand side here, these are the regular microplastics, but then as they get smaller and smaller and smaller, they can be smaller than the width of a strand of DNA. They can be the size of the COVID molecule, or parts pp 2.5. Those are the particles that we worry about causing asthma and all kinds of other major respiratory and cardiovascular issues, because they can slip right across the alveoli of the lung. Nanoplastics can get smaller than that. So we're looking at something with the capacity to get very, very deep into us. This is a comment from Philip Landrigan, who is a medical investigator who I worked with for a while, a couple of years ago, who's been pretty vocal about plastic pollution or plastics in general. He says plastic pollution is visible to everyone everywhere, but it's also invisible everywhere. As we learn about the penetration of these micro and nanoplastics, it's really causing people to sit up and start to wonder, what does it mean? And so that's actually how it is that I came to meet Philip Landrigan. I worked with him on this report here. It came out in the Annals of Global Health. It was the Minderoo-Monaco Commission on Plastics in Human Health. We started out as a team of 24 scientists internationally who looked at all of the published literature and tried to come up with an amalgamation of all of the known impacts of plastic on human health. And a year later, there were 48 of us. We were completely exhausted, but we generated this document. That was 2023, which actually makes this a very old document now because this science is moving that fast. But at the time that this came out, it was the first major document to try to track what does this mean for our health. And the person on the team who I felt was sort of the guiding light was this guy here, Christos Simeonidis, who said, look, we know a couple of things. We know what happens in the animal models when we expose them to micro and nanoplastics, meaning we feed it to them, we force them to breathe extra amounts of it, and then they get sacrificed, and we look inside their internal organs and we see what's happened. The animal models are doing very, very poorly. For instance, at that point, we already knew that zebrafish, when they ingested microplastics, they became demented. They swim in all kinds of crazy ways. We knew that the mouse models, that mother mice who ingested or breathed microplastics, that the fetal mice, the pups, had pretty aberrant behaviors and that they were full of microplastics. So we knew that. He said, we're probably going to see that in humans. And he said, the other thing that we know is what they're made of. We know that plastics are a petrochemical product. They're made out of fossil fuels and additives, chemical additives. And we know what those things do in vitro, meaning when you put them in a petri dish, if you put a living cell in a petri dish with plastics, it dies. And you know that happens up and down the range of different types of cells. Nothing thrives except for estrogenergic cancer. Nothing thrives in a petri dish. So let's think about this just for a minute. So like I said, plastic is made of carbon, fossil fuels, and chemicals. And depending on what you're making, if you're making something like a car tire, you can be looking at 30 to 50% chemical additives, which is fillers and that sort of thing. Food contact materials, much lower percentage, but still a very significant amount of what you're touching when you're touching plastic is a chemical additive. This was the most recent analysis as of 1 year ago. When in the Minderoo report, we thought that there were 1,300 chemicals in plastics, and a year later, we had 62,325. So that's how quickly this is moving. But of those 16,325 chemicals that we know go into plastics production, 26% of them are outright hazardous. Now, what does that mean? That means they are carcinogenic, full stop, or they're neurotoxic, full stop, or they do something called endocrine disruption, which I'll get to more in a minute, but they interrupt the hormonal systems in a living body. 66% of the chemicals in plastic are entirely without information. We don't know anything about them because the way that plastic is regulated or not regulated, the chemicals are regulated or not regulated in this country, is that you only have to show a hazard profile if they are involved explicitly with food. So, if it's food, yes, you have to demonstrate that it's not harmful. But if it's not food, if it's food packaging, if it's, a food adjacent, no problem. You don't have to demonstrate much. So this actually, we don't know what it is. We call that the unknown unknowns. And that's the thing that bothered Philip Landrigan the most. In any case, though, here's where we are with plastics production. We're making a lot of it. And plastic production and chemical industry production are hand in glove. 20% of the American economy is caught up in the petrochemical industry, and these guys move together. So as we go to create more plastic, we also are going to create that much more plasticizing chemicals and fillers and additives and so on. And given the hazard that we know those chemicals are, I look at this graph, and I said this to a scientist named Pete Myers, who is someone who's been working in this field since the 1990s. And Pete's actually the guy who coined the term endocrine disruption. And I said, Pete, this looks like trouble. When I glance at it, I actually think that the word unsurvivable, based on what we know about endocrine disruption, unsurvivable is kind of the story here. Am I just being like histrionic? Am I having a bad day? Am I overreacting? And he said, I think unsurvivable is a kind way of putting what this is. So here's one of Phil's slides, and I think this really puts a good point on what we have to worry about with plastics and additives, and that's this. Like I said, it's a polymer backbone of carbon-carbon bonds, and they're super strong because they're covalent. But and there they are. But it's also all these additives, and a lot of them are ones we've heard of: phthalates, bisphenols, PFAS, brominated flame retardants. We can just put those on the do not eat list, right? When you add those to plastic to give it its shape, its color, to make it water resistant or UV resistant or whatever else, they are not bound to the molecule. They simply sit inside the molecular matrix, which means that at any given point in the plastic's life cycle, I don't know about the word cycle because it never actually ends, right? It's never over. But at every point, these chemicals migrate out. And that's especially true if you apply heat. So if you take one thing away from today's lecture, it's this: do not microwave anything in plastic, because that added heat energy will increase the rate of chemical migration. Just in general, though, plastics and food contact are a very bad idea. For the same reason that we don't eat off of lead plates anymore, eating off of plastic is not a good idea. But that's just what you're eating off of. So what about all those micro and nanoplastics that we're hearing about in the human body? And Christos said this to me. He said, we think of it in a Trojan horse kind of way. Those plastics get into the human body, and some of them stick around. We're probably passing more than 90% of them. But the ones that stick around, that cross the intestinal lining, because they're nanoplastics and they can, or that cross the alveoli of the lungs, they're embedded in human tissue. And as long as they're there, they're still going to be leaching out their chemical contents. So they're little Trojan horses just leaching out for as long as they're sitting there. Well, at the time that we started the report, we were still just beginning to get a sense of where the there was. The most interesting finding came out in January of 2021, which noted that there were micro and nanoplastics on both sides of the placenta. And this got a lot of attention because it's the fetus, so people worry about that, but specifically because of the idea that nothing is supposed to cross the placenta. The placental barrier is supposed to keep the fetus completely safe from the outside world. So we knew in January 2021 that that was not the case. But even while we were researching the Minderoo report, if you were watching the literature, which we were, it was coming out like a drum beat. Lungs, May 2021, meconium, which is the first stool of a newborn infant. So before they've eaten anything, this is their stool. June 2021, sputum, blood, breast milk, liver, urine, veins, testes, heart tissue, kidney, February 2024. Oh, the blood finding, that came out while we were actually gathered as a Minderoo team. And we all looked at each other and thought, blood-brain barrier, anyone? If it's circulating in the blood, what's going into circulation in the brain? Well, we didn't know, but that was the next sort of frontier because we already had that concept that it couldn't cross the placenta. So if it can cross the blood-brain barrier, we're in a whole different kind of trouble. This was the next major finding that came out. Again, this was about a year ago now, and this was a study that was based on patients who had plaque in their carotid arteries, and so they underwent endarterectomy, which is it's kind of a roto-rooter, to put it gruffly, and they take out the plaque. And of these patients, they tested the plaque for micro and nanoplastics, and 58% of the patients had nanoplastics in their arterial plaque. They then followed them forward to see what was the outcome of this study group, and they found that those who had plastic in their arterial plaque had a 450% increased rate of heart attack and stroke over the people who didn't have nanoplastics. Now, correlation is not causation. We don't have the causal mechanism here, but this was an extremely robust finding, and it sent a pretty large signal that we're looking at something that's fairly significant. The next study that got everybody's attention came out in preprint last summer, and actually it just came out in its full printed version a couple of weeks ago, and this answered our question about the blood-brain barrier. This was a study team that they took tissue from decedents, so autopsy tissue, from two different groups of people. One group had died in 2016, and the other, I think, around 2023. And rather than getting in there with Raman spectroscopy and microscopes and trying to visualize the plastic, they used a different kind of technique where they dissolved all the biological tissue and then looked at what plastic was left. And when they did that, they found, they were looking at liver, kidneys, and brains from the same people. They found that the total mass concentration in brains increased over 50% in 8 years. So the first group of people from the first period had 50% less microplastic in their brain than those who died later. First of all, okay, that told us something right there. Yes, there's a lot of microplastic in the brain. In fact, they found quite a bit. But it also said the rates are rising extremely fast across the entire study group. That was interesting. They found that polyethylene, that's the stuff of plastic bottles, plastic bags, some of the most common disposable plastics. Polyethylene was the most common polymer. And then this one, this is chilling here. MNPs are what scientists call micro and nanoplastics. They found that they were selectively accumulated into the human brain, meaning there were more of them in the brain than there were in the liver or kidneys. One reason for that is that the brain doesn't have any flushing mechanism. There's no cleaning the brain except in sleep, I suppose. But it's an entry-only kind of organ, and that's good for information, but bad for microplastics. But the other reason is actually even more telling, which is a lot of the chemicals and even the molecule itself in certain situations are lipophilic in plastics, meaning they're attracted to fatty tissue. They're attracted to fat, lipids, and they dissolve into lipids and then they stay there. And the brain is the second fattiest tissue in the human body. The first most fatty one is adipose itself, so fat itself. But so micro and nanoplastics selectively move into the places where there's a lot of fat, and that includes, for instance, arterial plaque, which is, I think, why they think they found so much of that from that procedure. They also found a very strong correlation between dementia and Alzheimer's and the presence of plastic. Now, we don't know which side of the horse versus the cart we're looking at here, whether those plastics caused Alzheimer's and dementia or whether they wound up hanging around, brains that were already injured. Of course, if they can't really be flushed out of the brain, then they're hanging out no matter what. They're looking into that. But it was a particularly interesting finding. So this is really stressful. So here are some kittens, just for a couple of instance. These are mental health kittens. Take a breath, let it out. Okay, I'm gonna keep going. So the endocrine system, this is the thing that Christos was really worried about, and basically all of us are really worried about. So the endocrine system is a network of glands that create and release hormones like estrogen, testosterone, melatonin, and insulin. Those are the familiar ones. That network regulates all the biological processes in the body from conception through adulthood and into old age, including the development of the brain, the nervous system, the growth and function of the reproductive system, metabolism, mood, blood sugar, immune system, among others. If your endocrine system doesn't function properly, then neither does your body. Just think about diabetics and insulin. When endocrine disrupting chemicals impact our bodies, they impact necessary systems absolutely everywhere. So they'll impact the hormones that regulate our appetite and metabolism, and they will cause obesity, diabetes, high blood pressure, and heart disease. They can also cause cancers, especially breast and prostate cancer and testicular cancers. All of the cancers that are on the uptick are heavily influenced by the endocrine system. The timing matters the most with this stuff. If you are a developing person, if you are a fetus, a newborn, a toddler, a teen, an adolescent, if you're going into menopause, if you are pregnant, if you're at any major inflection point where your endocrine system is in overdrive, you're particularly vulnerable. But you're especially vulnerable if your body is still making itself. So it's especially the fetal period and the newborn period that we're concerned with, because what happens in the womb doesn't stay in the womb, and tiny, tiny, tiny doses matter. A developing fetus doesn't have a lot of signaling of its own. It has hormonal signaling. Those are the signals, the hormones, that activate the DNA and cause cells to develop in the ways that they're supposed to. So here's an example of a fetal vulnerability. This happens to be a map of the New York City subway system, but it's a great metaphor for what happens in the brain while a fetus is developing. Neurons are going to multiply and move super, super fast. And what they're doing is laying down the train tracks on which all of your thoughts and all of your impulses, your whole neural system is going to function once you've been born and develop into more of a cognitive entity. So while that's happening, like I said, it's moving fast. Those neurons are making literally millions of connections with each other. And if those connections don't happen in the way that they're supposed to, you wind up with track that's not going to carry thoughts or impulses in the way that it's supposed to. So the A train doesn't meet the one train. One thought does not lead to another in the way that it ought. And as a result of that, we think we're seeing a lot of cognitive impairment, frankly. We're seeing rates of autism, we're seeing rates of ADHD absolutely skyrocketing beyond anything that could possibly be justified by changes in diagnosis or even changes in diagnostic code. So for instance, autism is now 1 in 36. When I was born in 1977, it was around, 1 in 5,000, something like that. 1 in 36 is not corrected for by the fact that the diagnosis of autism now also includes Asperger's, or that girls are now looked at for autism also. 1 in 36 is a really big signal. We see it for ADHD also, and part of the reason that we think that this is an endocrine issue is because it is so preferentially happening in boys. Girls don't have nearly the same profile as boys. And actually, Christos his team published some research in August of this year where they looked at mice, and then they also looked at 2 different birth cohorts of children. And they found that if the mother mouse and the mother human had higher levels of bisphenol A, if she was more exposed to bisphenol A, and in the human section, they had urine specimens, and they also had cord blood. In the mice, they were dosing them preferentially. Higher bisphenol A reduced an enzyme called aromatase. Aromatase is involved in the translation of androgen into estrogen. So it impacts boys in fetal development at a very particular spot. They found that in both the mouse cohort and the human cohort, bisphenol A exposure causally resulted in higher levels of autism spectrum disorder. So that was interesting. That came out and it didn't get picked up by the American press particularly much. So we're going to see what happens with that as the press. I'm actually involved in a team that's trying to get it noticed a little more. Because the other thing that they discovered was that there was actually a fatty acid, a naturally occurring fatty acid that, if applied at birth, reversed the impact. Now, there are a lot of different ways to get to autism. Autism is more of a kind of a description, like a stomach ache. So that can come from a zillion different things. But this is one path that we've actually managed to figure out, and it's a plastic one. But here's a whole lot of other paths that we're taking a look at. These are all the diseases that are on the uptick, even when corrected for age. So we're looking at more cardiovascular disease in younger people. We're looking at liver disease, mental disorder, respiratory diseases, and so on and so on. One you might have heard of is colon cancer, happening in younger and younger people. And even when you correct for population and age and all the rest, we're seeing that these are all on the uptick. This cannot be part of our genome. This is not a genetic thing. This is happening way too fast. We absolutely know that this is an environmental exposure. And we absolutely know that the thing that has changed most in our environment is our general exposure to petrochemicals, from pesticides and all of the things that Rachel Carson pointed out in the 1950s to our current spectrum of plastics, which humans are preferentially exposed to plastics because we eat off of them. We eat in houses and handle things and so on that are very plastic more of the time. So that's another something we're looking at. Here's some kittens again. We'll just take a breath, let it out. Okay. So why is this happening now? And here's the Citizens Climate Lobby connection, right? This is a historian's question too. We always want to know, like, why didn't this happen in 1980? We had plastic in 1980. You know, why right now? Well, the first answer, and this is Matthew Campen, who's the author of the Brain Study. He says, okay, those background microplastics, yes, you're getting micro and nanoplastics anytime you're eating or drinking anything that was exposed to plastics, because they luff off like skin. Plastic just continually sheds. But most of it is probably coming from what we call legacy plastics, or toxic debt, meaning that 10 billion tons that's hanging around in the environment is degrading and has been for decades. So we're reaching kind of a tipping point where more and more nanoplastics are in the air, the water, the soil, the food. So we're picking them up more now. That's his theory. Here's another one, though, the climate crisis. And this is counterintuitive, but it's what I said about that pivot away from carbon fuel, fossil fuel, and into using those same things, petroleum, fracked gas, to create plastic instead as a way of extending the market for a commodity that's pretty hot. And, you know, it's pretty undeniable right now with the climate crisis. You know, last year was the hottest on record. There were quite a few days there where it was the hottest in 125,000 years. And I think David Wallace Wells pointed out that we're now living on a planet that's hotter than the one that the human species evolved to live on. As a result, quite a lot of people and quite a lot of nations are pivoting to renewables, including and especially China, are building EVs out at incredibly fast rates. And this is great. This is amazing. You know, if the US pulls back and decides to drill, baby, drill and become a coal mecca again, well, we may do that, but we may find that we don't have international markets because so much of the rest of the planet is moving over to cheaper renewables. So we've gone from plan A, which was fossil fuels, to plan B, which is single-use plastics. But there's another aspect of this that's a climate problem, and that is, of course, that plastic itself is made out of fracked gas or oil. In drilling for it, in refining it, and then in manufacturing, you have an enormous input of energy. And so some of that, actually most of that energy is coming from fossil fuels, but then you're also using those fossil fuels to make the plastic. So it, again, every phase in its life cycle, it's energy intensive, it's fossil fuel intensive, and at every phase, that's a climate problem. This, for example, is the amount of fossil fuel required to manufacture a plastic water bottle, and then even more to move it to wherever it's going to go at the point of sale. Tap water is far less energy intensive. If plastic were a country, it would actually be the fifth largest greenhouse gas emitter after Russia and ahead of Brazil. So this is a climate problem, inextricably linked. Also, not all plastic is created equal. Some plastic uses a lot more GHG gas or generates more than others. Now, this is a general schematic of the growth of plastics. 4% annual growth is kind of where we are at the moment. Even if we manage to decarbonize the entire rest of the grid, we're still using enough fossil carbon in plastic that we won't manage to reach our climate goals if we continue to produce plastics the way that we do now. So how do we solve this? Like I said at the beginning, I'm in this game because I find it solvable. I think that there truly are solutions, and they're not even that difficult. Regulatory systems are the most inefficient and the most just. We got to turn off the plastic tap at the top. About 44% of all the plastic currently under production is single-use plastic. Most of that is packaging. Most of that we didn't need. Those were markets that were created in order to have some place to put the plastic. And that's what we saw a lot of since 2000. We can turn that off. And there's an enormous amount of public appetite to do so, even and especially in the United States. These posters were up. Actually, I was at a plastic symposium at NYU in September, and I'm not entirely sure who had these posters up, but they were nowhere near NYU. People care. They don't want microplastics in their brains or their testicles or anywhere else. 81% of US voters support reducing the amount of plastic that's produced, capping it. 78% of voters want national policies that reduce single-use plastics, and 85% of US voters support increasing the use of reusable packaging and foodware. This tells you that wherever people are still allowed to vote, they vote against single-use plastics. And these are some of those places. 12 states and over 500 cities and towns have a plastic bag ordinance in effect. That's the tip of the iceberg, but it's an important tip because it sends a message that plastic is not as safe as we thought it was. It's stable, but it is not inert. It's biologically active. A lot of it is estrogenergic. And here's one to watch, actually. In Montana, they had what's called a ban on bans, meaning it's illegal to pass a ban on single-use plastics. I'm not sure if that's the case in Texas. It may well be. A lot of states have them. This was legislation that was introduced and pushed by the American Chemistry Council to pretty strong effect in the very early 2000s. In any case, in Montana, this one was challenged in court as an abrogation of the right to self-governance by local ordinance. And it's also an abrogation of Montana has a right to a clean and healthy environment. It's a long story. They won, they lost, there was an appeal, blah, blah, blah. Basically, they won, and the Montana Supreme Court then overruled it. But then the Montana Supreme Court said, you know, we haven't heard the part yet about the clean and healthy environment. We want a jury trial about whether plastic is going to harm human health. So this is going to bring this whole discussion into a literal other court and publicize it and make it clear in ways that it has not yet been. So watch this space because it's the first court trial of the science itself. It's being lodged, I don't know, fought by the Cottonwood Environmental Law Center, which has 2 people on staff. It is a tiny, tiny place that is full of vim. So watch them and watch this case because it should become very interesting. And if you want to know more about the subject, I actually teach an entire class on it. It's a 7-week class. It runs for an hour and 50 minutes, and it's going to kick off real soon. It's at Bennington College, but it's online. And actually, this PM is Eastern time. I should have made that clear. So it's 6 p.m. for you guys, which might be even easier. All you have to do to enroll is register at this link through, this will take you to the Bennington site. And you don't have to be a Bennington student. You can just enroll. They do charge a $100 enrollment fee. But then you get 7 weeks of me and bad news and kittens, and quite a few guest lecturers. So thank you very much. I've been watching you sit there in despair and occasionally laugh and occasionally enjoy the kittens. So that's good. I look for, we don't need that slide. I look forward to the Q&A, and now I'll stop my share. Phew, that was a marathon.
Okay.
Questions?
Thank you, Dr. Megan. What I would ask you to do is if you go to, I think it's the React. Yeah, if you go to React at the bottom or in Zoom, you can raise your hand. So just so we can do this in a logical manner, if you would raise your hand and then I'll just call on you in order to ask your questions. So really outstanding presentation, Dr. Wolff. I
Oh,
thoroughly enjoyed it. I learned, it's just I learned a lot the first time and then and even more the second time. So
thank you. I'm putting the slide deck in the chat also. You're all welcome to my slides, and a lot of what I said is actually written in the notes too. So
and
you can have it.
two things to note that the link to your course is in the chat. And then in addition, if you're a CCL member, there's an automatic, if you just click on that link that's provided in the chat, you'll get credit for attending a meeting. So anyway, we'll start the questions with Larry Kramer.
Yeah, I had questions about you have microplastics and nanoplastics, and you have different links in different slides. So some places you say it's the 10th of a micron, some places you say the dividing
Mm.
line's micron and things like that. And I just wonder what it is.
So I believe that it's the 1 micron mark is the nanoplastic mark. I actually was just watching a webinar by Matt Campen, who is very concerned with the size of nanoplastics. He's the one looking in the brain. Yeah, I mean it's a little bit of a distinction without a difference until you get to the point where it can cross a human tissue, right? Like once it can move as plastic right through the intestine or right through the alveoli of the lung, or, and this is debated, is it moving through human skin? Is it moving through hair follicles and that sort of thing? Not really sure. That's really the differentiation that we care about, but one way or another, it's going microplastic, nanoplastic. So I can double check the Campen reference. The other place to look is Matt Simon's book, A Poison Like No Other, is the first like book length treatment of microplastic. It's already more than 18 months old, which makes it out of date in this science, although it's accurate. It's just not up to date. And I got my original numbers from him. So sorry if I presented in a confusing way.
Great presentation. Thank you.
Thank you.
If I could ask you a real quick question. It seems to me it's just odd that autism goes viral. I mean, it's been doing this for years related to vaccines, but it doesn't seem to have gotten the same reaction to microplastics. And do you have any, I mean, why would that be? It seems like there's, I mean, I don't know, I'm confused by that.
Yeah. All right. Well, so that question, it's a very good question, and it kind of begs at the nature of conspiracy theories, honestly. Like, when does one theory that, immigrant children are being trafficked through footlockers or something, like, why does that catch on and then something else doesn't? I believe that the paper that tried to argue the vaccine link actually made it into a pretty prestigious journal. And for some reason, the British Journal of Medicine, BMJ, British Medical Journal, jumps to mind. It was retracted. I mean, it was soundly trounced in the clinical literature, but the fact that it made it into the clinical literature in the first place was like the first thing. But also, if you take a look at who had an investment in making the argument, you often find that there's power and purpose behind some of these conspiracy theories. Like somebody is trying to get disinformation through. I was just at a conference where somebody had a slide that was like the difference between misinformation, which is information that is wrong, and disinformation is information that is wrong for money or political gain. In the case of the autism link, sorry, turning on a light here. Like I said, that paper didn't get picked up by the American or the European press. And I think a big part of it was that the paper itself was just incredibly complicated. I read it, Pete Myers read it, like we all read it, but there were a lot of really important findings in it. And you kind of get stuck on one or two and miss the other ones. I knew to watch for it because I knew Christus from Minderoo, and he'd explained the research. And I'd been like, wow, that's amazing. I'm going to remember all of that. And I went back to my hotel room and I wrote down the word aromatase, and then I fell asleep, right? So I waited for his paper to come out, and knowing that it had all of these many moving parts. And I think it was too sophisticated for the news cycle to pick up. But I think it's going to get picked up because this is a causal link to autism. This is one of those holy grails that we've been looking for. And the nature of the study was just so elegant and so difficult to refute. I mean, they demonstrated in mice and men at the same time through the same mechanism. So we'll see. We'll see what happens next. I think it actually might even penetrate the current news cycle, which will be amazing if that happens.
Great. Well, thank you. Dan?
Yeah, thank you, Dr. Wolff. I wonder if you've heard of omnidegradable packaging materials. I have a relative in Canada that started a company that they manufacture packaging materials that break down in landfills through the use of microbes. It
Okay.
breaks down in landfills and oceans.
Okay.
And it's mostly bags and pouches, from what I saw
Yeah.
from the website. But I actually called the company and spoke with one of the representatives for a while. And they're working with another company that's trying to develop heavy plastics that will degrade in landfills and oceans. And I understand it takes a year or less for it to completely break down into an organic biomass. So that sounds pretty promising. I
Yeah.
was just wondering if you ever heard of such a thing.
It sounds great.
Yeah.
What I've learned from my research is that if it sounds too good to be true, it usually is too good to be true. And there are a bunch of places where it's pretty easy to poke holes through claims like that. I mean, the easiest thing right now is, well, how scalable is it, right? Like we're dealing with hundreds of millions of tons of plastic.
Yeah.
And so whatever it is, we need it 10 years ago. We need it 20 years ago. There are actually bioplastics that have been under development since the 1980s that are ready to roll and actually do break down. But even the companies that have been working on those know that they're not scalable in anything like 50 to 60 years. So that's the first problem. But the next problem is breaks down into what? Like when companies argue that something is, fully biological and compostable, they're usually burying a number of the elements in it. So plastics, you can make them out of anything. They don't have to be made out of fossil carbons. They could literally be made out of carbon derived from feces. It doesn't matter where the carbon came from. The bonds are the important part. Those carbon-carbon covalent bonds are not going to break down. There are some tricks. There are some ways in which you can kind of embed enzymes that are then more easily reached, and they'll break down from polymers, really long polymers, into short chain polymers or monomers. But those are still plastic. So for instance, PLA, which is that form of plastic that they make laundry pods out of, that dissolves into water, it's not dissolving. It's becoming microplastic. It breaks down into monomers and short chain polymers that are then in the water. And now they're in the biocycle. And guess what? Those are nanoplastics. So they're the more pernicious ones anyway. So most of these products that claim that they, break down and so on and so on, yeah, they're breaking down, but they're not composting. They're just fragmenting beyond our capacity to see them. Another issue with these is that in order to make it act like plastic, you still need to add the same suite of additives that you added to conventional plastic. So you still have the phthalates, the bisphenols, the brominated flame retardants, you still have that. So when that breaks down, that's what's going into the compost pile. And then, stuff about landfills kind of gets under my skin because landfills are almost always anaerobic. Most of what goes into landfills is totally inert for hundreds of years. You can look down into an old style landfill and find newspapers from the 1940s that are still readable. Things don't break down in landfills. That's not what they're there for. They're kind of more storage. So frankly, putting conventional plastic in the landfill is the best thing to do with it because it's going to be more inert. So a company that claims that something is going to break down in a landfill gets my antenna up right away because I know that's not how landfills function. So alas, not usually a solution. I mean, it's interesting because it's economically boring, but we don't need moonshots to solve this problem. We have all of the materials that we need. We need to move away from the concept of the throwaway lifestyle of disposability. And in a different version of this presentation, I get into where that came from. That concept came from the plastics industry. It was marketed to us in the 1950s. If you have a disposable plate or disposable cup and so on, you've now created a perpetual market. You don't have to, if you take the idea that the item was so cheap that you have no incentive to wash it and put it away, you can just throw it out, guaranteed you're going to buy another one and another one and another one. And that was incredibly savvy. These are the smartest people in the room. They knew what they were doing. So they managed to create an entire lifestyle around a product that we didn't have more than 80 years ago, and we never needed until we changed the way that we function around it.
Hey,
Next question.
Zelma?
Yes, thank you so much. And thank you, Dr. Wolff. This is fascinating. My most inspiring thing I saw was you had a card that told about what percentage of voters disagreed with plastics and were taking that interest. I think that's something that we can look into and build on. And I wanted to say that I attended a class at Baylor College of Medicine to get a Target gift card, and they wanted to talk about plastic cancer, but they didn't talk about plastic. They've got the CAT PAW, Cancer Alliance of Texas, and they've got a priority area working group, CATPAW. But we went through the whole list of environmentals, radon, formaldehyde, all kinds of things. And I raised my hand and I said, I don't see plastic on here. And they said, that's right. That's not part of our area of focus. So you ask why these things aren't being focused. We're in Houston, Texas, the Petro Metro. Follow the money. Nothing new under the sun. I'm just going to say it. I'm an old Quaker. I'm allowed to say what I want. I'm old now. But I just want you to know you just gave me some new inspiration. I'm going to try to get somebody enrolled in your class, someone that can catch on and younger and so forth to present to the community, because this is a pseudo information. It's not a lie. It's an omission. And so when we look at how many young people, we have big neurodivergence in our little barrio here, lots of autism, and lots of people really believing it's from vaccines. So I see where the work is to be done. I want to thank you and bless you, and thank you all for the grace and space.
Thank you.
No.
I will say, actually, a question I get quite a lot is, where are the doctors? Like, why didn't my doctor tell me about this? And that's why I created PSNAP. I was the medical health policy director at Beyond Plastics for 3 years and change. And I noticed that people sit up straighter. They take more notice when it's a physician or a scientist who gives them this information. It can be exactly the same information, but if you've got an MD, people are going to listen to you more. And I also noticed that, well, okay, there are some physicians who are interested in this, quite a few actually, but it's just like the lay audiences. Some people have heard about it, others haven't. So my organization is designed in part for doctors to talk to doctors, to go into grand rounds, to go into residency programs, to go to professional meetings and make sure that this is on the agenda to get it through in medicine. So I'm getting an appointment at a medical school this summer to start teaching my class inside a medical school. And like, that's the point. So thank you for that, Selma.
Okay. Franz, you're up.
Yeah, I had a fantastic presentation. I'm going to have some wine in a glass to down my pessimism. I have one comment which relates to the renewable and energy industry. Eventually, we're going to have to get rid of all these turbines that are out there and solar panels, and lots of them have lots and lots and lots of plastic in it. So we shouldn't forget about that. But the other question I have is, I've read a lot about some companies that are trying to use other materials than fossil, or other sources than fossil fuels, to make plastics. Yeah, well, call them plastic substitutes.
Yeah.
But the way I understand it is, there's still these long form molecules. They're still going to have to use additives. So that is not going to really solve this microplastics problem. Or am I wrong there?
No, you're precisely right. I used to have a slide in my deck that was labeled false solutions. You know, the idea is to put our minds at rest. So, for instance, the concept of mechanical recycling for plastic, that was a false solution, otherwise known as a lie. It was innovated by industry to put consumers at ease about purchasing plastic, because if they thought it was recyclable, they would chill out. And that's what happened. Although almost none of it is recyclable. And in the US, about 5 to 6% of what we throw into our bins ever gets recycled. So the bioplastic thing is another false solution. And you're exactly on point as to why, is you're still using the same suite of chemicals.
Okay. I've got actually another follow-up question. So it seems like there's a lot of parallels with the kind of climate and the oil industry here, where the parallels would be where the oil and gas industry, has a culpability in the problem with the climate crisis. But I'm full disclosure, I'm ExxonMobil, retired, and I know that they had a group of scientists that were studying climate issues, and they completely knew about it. But is there anything parallel going on where they are publishing anything related to the nanoplastics? Have you heard of anything like that?
Yes. So the current push from industry is to try to continue to claim that plastic is inert. And therefore, if it's in your gonads or it's in your brain, it's just fine because it's not causing any problems. It's just sitting there and hanging out. And I've seen some interesting inroads. I've seen the National Academy of Science platform right next to physicians who are researchers on the same panel. You know, a dude from Dow Chemical who doesn't have any kind of degree, who's just there to say, oh, it's inert and look pretty and say it, forcefully. And, the National Academy of Sciences is holding on to its funding and putting up people like this. We've seen this for decades. I mean, we call it the tobacco playbook. Create fake science, create fake scientists, make sure that they get onto, the panels where they're recognized for something, whether or not they have real credentials or whether or not they're being very well paid to say something that is not scientifically robust. We've seen it before. So they're doing that. I don't know what their studies are. I haven't seen any studies yet. But I am pretty discerning about whose studies I pay attention to and whose I don't. I know where to read and I know who to talk to. So I'm pretty good at filtering the disinformation.
Well, and I haven't been real good about checking the chat, but there's a question here from Judith about lots of individual actions we can take about to reduce plastic and not drink out of plastic
Hmm.
things and so forth. Is there a
Yep.
list that's you can provide that like these are the things, the major things you should avoid doing?
Yeah, I think the rules of thumb here are don't eat off the stuff, which go into a grocery store and then try that on it. Like, okay, actually, the best rule of thumb of all is this is not your fault. You didn't create this problem. This is a structural problem. You were born into it, and living in society as a human being now, you're not going to get away from all the plastic. A friend of mine wrote a book called A Year of No Garbage, which was her attempt for a year to not have plastic in her life, and she's a humorist. So it's one of the very few points of humor in this whole story, but it is hilarious. So thing number one, don't beat yourself up. Thing number two, change one thing at a time. Go for one thing. And as far as I'm concerned, that thing should involve food. So if you can get a glass version of that food, buy it in glass. Anything that you can buy not in plastic that's a food item, it's going to cost a little bit more, but it's not in plastic. And that's going to be good for your body and for your health. Throw away the kitchen plastics. Replace your Tupperware with Pyrex. You go back to ceramics. Go back to Teflon. Do not use coated pans. Those are directly additives. If you've ever heard the term Teflon flu, like that is for real. Move back over to stainless steel. So it's the food stuff to watch out for the most. But again, like don't starve yourself because you can't find something that's not in plastic. If you go far enough out, you're going to be baking all of your own food, all of your own bread, and growing your own wheat, and you're going to be a crazy person off the grid. There are some things to be recommended for going off the grid right now, but I'm not going to say it from this pulpit that like that's the answer. But take it stepwise. Every time you're purchasing something and you have the opportunity to buy something that's not the plastic version, go with that. You might not have the opportunity. In all of my previous lectures, I've always stressed civic engagement. Our voices are louder than our dollars, and that's still true. So writing a letter to the editor, talking to people, anything that you can do to be loud is good, but it's especially good if you can do it in a structural place. Now, I know in Texas, local politics are not going to really be with you, but institutional politics might be. So trying to get reusables in schools, at church or synagogue or whatever, ecumenical organizing platform, have a plastic-free coffee hour. Things like that get people thinking differently about using the plastics and trying to flush them out of their lives and change their habits. So those are all things. One last one to think about, phthalates are an additive that phthalates are very good at conveying scent. So scented candles, scented anything, particularly personal care products, usually have a lot of phthalates. You read the labels on your personal care products because those are things that are going directly onto your skin and directly into your body. So if you're concerned with your own health, moving away from those kinds of products is also high on the list. But again, don't do it all at once. Don't drive yourself crazy because you won't make the switch. Just do it piece by piece for the things that are like the lowest hanging fruit in your lives.
Okay. And what I'm going to do now is I'm going to stop recording.